So let's look at another example here with ideal gas law. PV is nRT, which is 8.31 T. So if we solve that for V, we get V is 8.31 T p to the negative 1. Well, we want to find the rate at which V is changing. So that's going to be dV dt is what we want. When P is 1 and increasing at 0.1 kilopascal per second. So P is increasing, that's a rate of change of P. So we know here that dP dt, that rate of change, is equal to 0.1. And T is 250 and decreasing at 5 degrees Kelvin per second. So that is telling us rate of change of temperature with respect to time. That's a derivative, dT dt. And we know that that is negative 5 because it's decreasing, so negative rate of change. So, and this is what we want. So we want dV dt. So let's formulate our chain rule here. So V depends on T and P here. And then each one of those depends on time. So if we write out our chain rule, dV dt, we're going to put derivatives on the branches. So this will be dV d cap T, temp. This will be dV dP. And then here we'll have dt dt and dP dt. And you multiply down the branches and then add up the separate branches. So this will be dV dt temperature times dt dt plus dV dP dP dt. So we already know these guys, this one and this one, were given right here. So, and then these two derivatives we can compute. So dV dt, the t derivative of volume here, so that means t is our variable, 8.31 p to the negative 1. That's just a number, that's a constant. You differentiate a constant times t, you get the constant 8.31 p to the negative 1. So we could write that 8.31 p to the negative 1 dt dt plus, and now we want the p derivative of v. So now p is your variable, 8.31 t is a constant. So to differentiate that, negative 1 comes down in front. So negative 8.31 times t, and then decrease your exponent on p to the negative 2. Which we could divide by p squared if we want. And then times dP dt. So our derivatives here are written in terms of p and t. So our p value here is 1 and our t value is 250. So now we can just plug those guys in. So 8.31 and p to the negative 1 is dividing by p. So divide by p is equal to 1. And then dt dt, that is negative 5. And then minus 8.31. T is on top, t is 250. And then we're dividing by p squared. So divide by 1 squared. And then dP dt, that's 0.1 right here. So now everything is numbers. If we go ahead and plug into the calculator, we will get negative 249.3 to 1 decimal place, and that's going to be liters per second. So that's chain rule in an applied problem.